Hey everyone, welcome to 2.1 Function Notations, where we are going to be putting the fun in functions. Let's go ahead and get started. So to review at the beginning, let's review finding the value of y. Finding the value of y for the function y equals 2x minus 4 when x is negative 3. So we're finding the value of y for the function y equals 2x minus 4 when x is negative 3. So this is pretty simple. It's just a simple plugging in of an x value of negative 3 into the function and letting the function do its thing so that you find the y value. We will multiply first to get a negative 6, subtract 4 to get a negative 10. So the value of y is negative 10 when x was negative 3. So why are we talking about this? Well, because this is leading us into our work with functions. So what is function notation? Function notation is when we start writing, instead of y, f of x, because y is equal to f of x. And we do say f of x, not f parentheses x or f times x. It's a function of x. Y is a function of x. It's the value of a function when x is a certain value. Y is the value of a function when x is a certain value. Instead of saying y anymore, we say f of x. It's really just another way to write x and y coordinates. And let me show you how to do that, and then I'll explain to you why. So here's how we do it. X and y coordinates, instead of being x and y, would be x and f of x. Because remember, this guy right here, he is y. So instead of writing y, we're writing f of x. So let's say we have this ordered pair, 5, 7. And that is x and that is y. And we want to write this ordered pair in function notation. Well, basically, f of 5 is 7. Let's take a look at what I did there. F of x is y. Right in here is your x value or your input, and out here is your y value or your output. So when the function was 5, it gave us 7. When the function was a value of 5 for x, it gave us a value of 7 for y. So this is another way to write this ordered pair in function notation. These two mean the same thing. Same thing. So let's take a look at another example. Here's 0, negative 5. This is an x and this is a y. So f, the function at x value of 0, gave us a y value of negative 5. The function at an x value of 0 gave us a y value of negative 5. So again, this is in function notation, this is in regular xy coordinate, and these also mean the same thing. So why do we do that? Why do we even care about function notation? And really it's because it's an easier way to see the pair that goes together. Let's go back to that first example. We can see in this first example, let's make that a little bigger, that y is equal to negative 10. Okay, but we have to go back to the original problem to see what the x was. If we would have written this in function form from the beginning, right there, f of negative 3, f of negative 3, right here we would see plain and simple that when x was negative 3, y was 10. So it's just a cleaner, faster way to work with functions to be able to see who the y value is with the paired x value. That's really why we learn this notation, this more advanced notation. So let's move along. So what if we wanted to write it from function notation back into xy format? So I wrote g of negative 6 is equal to 0. Now where's this g coming from? Basically, functions can be any letter. F of x, f is like the standard way we use it, but we can also call functions g or h or a or any letter, and sometimes we use letters almost like If it's a cost function, we'll use C. If it's a, I don't know, any other interest function, we'll use I. The letter is really just whatever you want to use as the letter. So yeah, F is usually the one you'll see a lot, but we can say G of -6 is equal to 0. This is in function notation, so let's write this XY coordinate in XY form. So this is the X, and this is the Y. So again, G of X is equal to Y. This is your X value, and this is the Y value that came out when we put that X value into the function. This Y value popped out. So these two guys, -6, 0, and this function form, these mean the same thing. I know how to spell same thing. Okay, so let's try one. Let's see here. Find f of -4 for f of x equal to -x minus 7. So we have some function here called f of x is equal to -x minus 7, and we want to find f of -4. Basically, this is just telling us to make x equal to -4 and find y. Make x equal to -4, change him out for a -4, plug in that -4 and find y. So f of -4 is -4 minus 7. So again, x used to be here. F of x is equal to -x minus 7. F of -4 is equal to -4 minus 7. Used to be an x. And now we're just going to do the math. So it's 4 minus 7, also known as -3. So f of -4 is -3. And to extend on this concept that f of -4 is -3, that means that we've got an ordered pair -4, -3. And for those of you that didn't know, this right here, that's actually a line. And that line will contain a point at x -4 and y -3. There's just a little bit of information on how it all kind of links together here. So again, that is a line. This function does create a line if you were to put this into your graphing calculator, or if you just knew that that would make a line. And this line would have a point at x -4, y -3. I'm going to have you try an example now, and then you'll go ahead and put that answer in. So let's see your example. So here's your example problem. Let's say the function h of a is equal to 2a to the third minus 2a. Notice in this function we called it h, that's just the name. And instead of x as our variable, a is our variable, so a is our input. H of a is 2a to the third minus 2a. Your job is to find h of 3. Go ahead and do that now. All right, and for this next example, we have g of b. So function g with variable b is equal to 3 square root of 2b. Your job is to find g of 30. G of 30. Go ahead and do that now. So let's go ahead and take a look at this problem. It says g of x is equal to the absolute value of x minus 1 minus 2. And we're given a table of values followed by a graph. And our job is to complete the table of values and then take those table of values and translate them into the graph of this function. So pretty simple stuff where we will just take each x value, plug it into the function to get the corresponding y value. Remember, g of x means y, so again, this is in function notation. If I take each x value and plug it in, I'm looking at the first one, the absolute value of 1 minus 1, which is 0, and 0 minus 2 is -2. In the next problem, I'm taking the absolute value of -4 minus 1, and that's -5. So the absolute value of -5 is 5, minus 2, that's 3. And for the last x value, I'm taking an x value of 5, putting that into this function. That's the absolute value of 5 minus 1, that's 4. 4 take away 2, that's 2. So what I have here are 3 points. 3 points that live on this graph. So let's go ahead and plot these 3 points. When x is 1, y is -2. So that is here. When x is -4, y is +3. that is here. Sorry about that. And when x is 5, y is positive 2. So that is here. And then we will go ahead and connect the dots to those graphs nice and neatly. And there is our graph for the function with 3 ordered pairs. There are clearly an infinite set of ordered pairs on here, but those are just the 3 that were chosen for us. And that's that. But that's not all. That's not really the meat of this, because we can work in another direction too. Let's take a look at this direction. Let's say that f of x is equal to this equation right here. So f of x is equal to 2x over 3 plus x over 4. And our job is to find f of x is equal to 22. So basically what they're asking us to do here is that they're asking us to find x. Isn't that weird? They're giving us y. Find f of x equal 22. Find the x value when y is 22. Y is 22. Ooh, how do we know y is 22? Well, we know y is 22 because they're saying f of x, which is y, is equal to 22. So again, we are looking for the x value when y is 22, when the function is 22. So in order to do this, it's just an Algebra 1 concept of adding fractions, but I really need you to understand the functional component, the fact that we are given y and we're finding x. Let's go ahead and do the algebra part of this. So first thing I want to do here is clear the fractions, and I'm going to go ahead and clear those fractions by multiplying by a common denominator of 12. That will help cancel these fractions out. That gives us 264 is equal to 8x plus 3x, and that's because 12 canceled with the 3 to make a 4. 4 times 2 is 8, and 12 reduced with the 4 to get a 3, multiply with the x to get 3x, and we have to multiply 22 by 12. So we're looking over here at a 264 is equal to 11x. Divide by 11 on both sides to get that x is 24, but we will express this in function notation. F of 24 is 22. When the x is 24, the function is set at a y value of 22. So that's a little more of an advanced concept because we're looking at a problem from a different perspective. All right, so I'll go ahead and do another one with you. Let's say we have k of x is equal to the absolute value of 2x minus 3 minus 2, and they tell us find k of x equal to 15. So basically, y is equal to 15. What is x? So the function k of x is 15, and we're looking for the x value when that function value is 15. So we are going to add 2 to both sides to isolate the absolute value. That gives us a 17 is equal to the absolute value of 2x minus 3. We are going to set this problem up. This is an absolute value equation. So 2x minus 3 could be 17. 2x minus 3 could also be negative 17. And this is from our work in the first unit, the concept of the absolute value equation and the 2 answers. We're going to solve each answer or each prospective equation for x. So 2x is equal to 20, x is 10 over here. Oh, that's a 10. And let's add 3 over here. 2x is equal to negative 14, x is negative 7. Let's check these answers. Let's plug them both in here. Just make sure our k of x value that we're looking at is 15. So if x was 10, let me get a different color for you here. If x was 10, 2 times 10 minus 3 minus 2. So that is 20. 20 take away 3 is 17. The absolute value of 17 is 17. Minus 2 is 15. That worked. And let's try negative 7. So I'm checking both my answers. 2 times negative 7 minus 3, that's 2x minus 3, minus 2. Okay, so absolute value of negative 14 minus 3, that's negative 17 minus 2. So absolute value of negative 17 is 17. Take away 2 is still 15. So my answer of 10 was good. Right here, right here. My answer of negative 7 was good. Right here, right here. They both came out to a 15. So I have two x values. I have two x values that make, oh, let's go back to that. I have two x values that make k of x 15. We have two of them. So how would we express that? Well, it's as simple as saying k of 10 is 15 and k of negative 7 is 15. Negative 7. Because both of these answers work. So that means that there are two ordered pairs on this graph that that will have a y value of 15, x value of 10, y value of 15, x value of negative 7. And I actually want to go ahead and take a second to show you that graph. All right, so right here I have graphed the function y equals 2x minus 3, absolute value of 2x minus 3 minus 2. And I went ahead and plotted the 2 points. And you could see they're right there. The answers that we got are both on the graph, and that's not a surprise because we got two answers that worked. That means that there's 2 points in the graph that give you a y value of 15. That's the ordered pair 10, 15 and negative 7, 15. So that's why we got two answers for x, because this particular function has two x values where that y value is true. And this is Desmos graphing calculator, DESMOS, and you can do the same exact thing in your graphing your computer or your phone or your iPad to see this live and in person. All right, our next one is going to require us to remember factoring. Oh my goodness. Let's hope and pray that we remember how to factor. And if we need help with factoring, it's a great time to ask during our work in our teams. So h of x is equal to x squared minus 2x, and we are finding h of x equals 8, which means that y is 8. And here's the rest of the function. So h of x is 8, and 8 is equal to x squared minus 2x. Now, if you don't remember, this is a quadratic, and since it is a quadratic, it needs to be set equal to 0. So 0 is equal to, and let's do that by subtracting 8 on both sides, 0 is equal to x squared minus 2x minus 8. So how do I know this is a quadratic? Because it has a square. It's not linear, it's not absolute value, it has a square in it, it's called a quadratic. And the way we solve a quadratic is by setting it equal to 0 and then factoring. How do we factor? We're basically asking ourselves what two binomials made this trinomial, and that is from Algebra 1, and we'll review that now. What two binomials made this trinomial? So I think about 8, and I'm like, well, that comes from a 4 and a 2, or an 8 and a 1. And I'm trying to make a 2. 4 and a 2, 8 and a 1, I'm trying to make a 2. It looks like I'm probably going to use the 4 and the 2. Let me go ahead and put my x and my x. And my signs are definitely going to have to be one positive and one negative, because this guy right here is negative. And since this guy right here is negative, we're going to put the negative on the bigger digit. And you can check that out by foiling. If you don't remember what FOIL is, that is the first, outer, inner, last. This is a great opportunity to give me some feedback and let me know where you're at with factoring and foiling. So do you feel comfortable with factoring? Do you know what I mean when I say FOIL? Okay? So let's continue for those of us that are okay with this information. Now that I have factored, I'm going to set each equation equal to 0 and get my answer. So over here I have an x is equal to 4, and here I have an x is equal to -2. I'd like to see those on the graph now. So here it is. I went ahead and typed the function in x squared minus 2x is equal to 8. You see that Desmos gives you the answers of -2 or 4. So that's very helpful of Desmos. So we want to make sure that we can use this as a resource to check our answers. So I know my answers are right. Now I want to show you in the graph how we can know that it's right. Here's the graph x squared minus 2x. So it is in green, the parabola. There's our first answer, 4, 8, and our second answer, -2, 8. And you can see that they are both points on the graph. So that is the graph equivalent of what it is that we're actually doing, which I think it's pretty cool to actually see it on the graph and see it come to life. So we have a few more example problems and then we are done. Let's check them out. All right, the first problem I'd like you to try, example 6, I went ahead and rewrote it here. Let's say f of x is equal to x minus 7, and I give you a table that's partially completed, some x values, some y values. Your job is to complete this table and go ahead and graph the function f on the graph. So go ahead and try that now. And last but not least, I'm just going to give you one example problem instead of two. This problem will see if you can remember how to factor. You can also check your answer on Desmos. Don't use Desmos just to give you the answer. Use it to help you get to the answer and help get to the process of factoring. So h of x is equal to x squared plus 3x. Find h of x equal to 4. Again, you are going to have to factor in this one, so if you're having a tough time factoring, please let me know, and I'll be sharing some links in Schoology for review on factoring. And yeah, go ahead and try this one. Find h of x equal to 4. You should be expecting 2 answers. And after that, if you can include a summary of what it is that you learned, that is it, guys. Big work today. Lots of new stuff on function notation. I hope you enjoyed the lesson, and I'll see you in class. Bye-bye.